In this unit, we're going to look at water properties, resources, and use. In your textbook, hard copy, Raven and Berg, this is chapter 14, and in the online textbook from Annenberg Press, The Habitable Planet, this is chapter 8. So why should we study water? One simple look at the Earth from space and we know why we need to study water. We've got this great big blue planet, as we're often called, and 75% of the Earth is covered with water, so it's extremely important to us because so much of the Earth is water. But more than that, another major reason we need to study water is because we need water to live. We can't live for a week without having water to drink. Our bodies need it, all animals need it. So it's a very important resource that we have to know about and take care of. The first thing we're going to look at are some water properties. If we're going to understand how water operates, we need to know about it to begin with. A lot of this you may remember from chemistry class, and if not, just pick it up as we go along today. A couple important properties of water. BP here stands for boiling point. 100 degrees Celsius or 212 degrees Fahrenheit. The freezing point of water is 0 degrees Celsius, 32 Fahrenheit. It has a high specific heat, a high heat of vaporization, expands when it cools, and it's a universal solvent. Those are just a quick summary. We're going to get into more detail on each one of those. As we said, water's properties, boiling and freezing points, that's standard whenever we're at 1 atmosphere pressure, and for most part that's pretty much our normal conditions in the Pittsburgh area. But it does vary if you change elevations, and you can see by this graph that if you go to a higher elevation, this is showing an elevation here of 2,400 meters, that's a pretty high elevation, then this side of the graph shows you that the pressure decreases as you go to higher elevations, and that's because there's less air above you, and so there's less pressure. And that makes it harder, more difficult for water to boil, and it actually boils at a lower temperature when you're at the higher elevations. And you can see up at that elevation, it actually boils at 92 degrees Celsius instead. Another property of water that is probably more important to us in our earth science class, environmental science class, is something known as specific heat of water. For this property, what it means is the amount of energy it takes to heat 1 gram of a substance or 1 kilogram of a substance and change its temperature by 1 degree Celsius. Sometimes they relate it by 1 degree Fahrenheit. The graphic here is trying to show you an example. If you had 1 kilogram of gold and 1 kilogram of water, and you put the same amount of energy to them, so the same flame, the same heat to them, you would change the temperature of the gold by almost 70 degrees. If you took that same amount of energy and put it to the water, it would only change its temperature by maybe 4 or 5 degrees. So that means water is actually very difficult to heat. It's kind of a unique property of water. Metals have a pretty low specific heat, only a value of like 0.5 to 1.2 or so. But water's value is 4.18 and has a kind of a weird combination of units here. Calories, or could be joules also. Those are units of energy. So that tells you how much energy per degree Celsius per unit of mass, because you can imagine that if you have much more water, it's going to take more energy to heat more water. If you want to change its temperature by a lot of degrees, it's going to take more energy to do that as well. Okay? So why is this property so important to us in environmental science? The fish love it, right? That's why it's important, okay? The main reason is the high specific heat of water provides a moderating effect on temperature. So if there's a big body of water like the ocean or a lake, the water in that lake or ocean takes quite a lot of energy to heat up. So it stays the same temperature for a long time. On the opposite way too, as it cools down, it takes a long time to cool down. It takes a long time to give up that energy that it has and change its temperature basically. So when you have a large body of water, usually you get temperatures that are considered just moderate temperatures, that the temperature kind of tends to stay the same more times throughout the year. So no extreme colds, no extreme hot cycles, but just kind of a moderate climate all the time. And again, that's good for animals that live in the water because their bodies probably can't take extreme temperature changes of a lake. Another important property of water is kind of gets into the idea of its shape. If you remember from chemistry class, water is a bent molecule shape. Here are the hydrogens, a hydrogen here, and the red is an oxygen. And because of the shape of this molecule, it makes a bent structure, and so this region, these two little symbols here, this means a partial positive charge, and this means a partial negative charge. So why does it take this shape and not just in a straight line? Again, from chemistry class, this oxygen has, not shown here, an unshared pair of electrons, actually two unshared pairs of electrons. So there's a whole bunch of extra electrons up in this region, 4 of them. I guess that's not a whole bunch, but 4 electrons in this region. And those electrons kind of push these hydrogens out of the way. Those electrons are not attached to anything, so they have kind of like a pushing effect, and so they'll push these two hydrogens closer to each other and giving water this bent shape. Right? That gives water also some other unique properties besides just being bent and being this property we called polar. But what it does is it allows for this water molecule to be highly attracted to this water molecule. And how would they be attracted? Well, it would be that this positive part of this water molecule is attracted to the negative portion of this water molecule, and we call that process hydrogen bonding. Now, I know a lot of times people might be a little confused by that term hydrogen bonding because it's not technically a permanent bond, but in this case with water, it is an extremely strong attractive force. So it's like they're almost working together all the time, and they do kind of stick together somewhat. So it's not technically a bond, but it's about as close as you're going to get. Another property of water that is important for, we'll be talking a little bit more about this in our geology section, water expands when it freezes. One of the very few substances that do this, and whenever it expands, it actually pushes these water molecules further away from each other, and in doing so, that's the property of water that allows it then to float in itself. So ice cubes, where are they at? They're at the top of your glass. They're not sitting at the bottom. Water on a lake, is it at the bottom? I'm sorry, ice on a lake, is it at the bottom of the lake? Nope, it's up at the top. So thank goodness water has that property, or we wouldn't be playing hockey here in Pittsburgh. Another important property, and the last one we'll talk about today, is the property known as universal solvent for water. I guess that's not really a property, but it kind of goes back to that bent structure. When water has this bent structure in that region of positive and negative charge, it's able to pull apart a whole lot of ionic compounds. So if there's an ion that's around a positive charge, all the negative charged parts of the water molecule are going to be able to pull on that and separate it. And all the positive parts of a water molecule able to grab hold of the negatively charged ions. Remember from chem, these are called cations, the positive, and the negatives are called anions. So it's able to be this solvent that can dissolve a lot of things, right? So what sort of things will dissolve? Well, water is in the ground. So the ground contains lots of minerals, things like sodium chloride, but also magnesium and calcium ions, chloride and sulfate anions. So all of those are things that are soluble in water. So as the water runs over rocks and minerals, it's able to dissolve some of those and carry those with them. The mineral or salt content does vary depending on whatever type of rocks you have and whatever type of soil there might be. Some soils tend to hold on to those ions better than others. Other types of soil don't do that. Right? So those are some of the properties that we have for water, and you should kind of get to know those general trends and properties of water, and that'll be one section for our information on water.